So out of which, like your entire course, you have 10 modules altogether, guys. All right, here you're going to learn your understanding. First two modules, you're going to talk about storage unit, like that is nothing but HDFS. And module 3, module 4, we're going to talk about the processing unit. Module 5, we're going to talk about module 5 and 6, we're going to talk about high level processing. Module 7, module 8, we're going to talk about NoSQL database. Module 9, we're going to talk about like in-memory processing tool called Spark. And module 10, we're going to discuss about Apache Uzi, Flume, and we're going to implement one of the Hadoop project as well. So this is what you have in your curriculum. At this point of time, you might not know about like what are the technologies, what is PIG, what is MapReduce, what is Hive, what is HDFS. But down the line, after 1 hour, you will get to know about like, all right, after taking this course for next 1 hour, you will get a complete overview of like what you're going to learn and what are the things where exactly it's going to fit in software lifecycle management. All right, so let's understand about like our first module called understanding big data and Hadoop. So here we're going to learn a lot of stuff like what is big data, what are the limitations. We're going to understand Hadoop and its features, different Hadoop ecosystem and their purposes. We're going to understand 2x core component. We will be learning about read and write operation in Hadoop. We will be learning about rack awareness concept, and I'm going to show you how to use Cloud Lab, all right, for all your practice. All right, so guys, now let's start our discussion with what is big data. All right, what is big data? Most of the people does have a myth about big data. What do you mean by big data, guys? Any answer? Be it be wrong or right, guys, you can answer anything. All right, I just want to check the understanding. So you can answer, all right, whatever till your best of your knowledge, you can answer. So let's make things more interactive. So big data is not only processing unstructured data, right? Big data means huge data, okay? Right, so most of the guys answer big data is nothing but huge amount of data. Now let's understand big data. First, let's understand what is big data. All right, so most of the people say if I have a huge amount of data, then I can call it as big data. So imagine that I have a 1 GB of data. Do you think it's a big data, guys? If I have a 1 GB of data, do you think it's a big data? No way, right? So now let's say that I want to process this, all right, I don't want to store this 1 GB data. I want to process this 1 GB data with my, all right, oldest mobile. Let's say that my black and white Nokia mobile, Nokia 1100. All right, where you have torchlight also. All right, so do you think my Nokia 1100 can process this 1 GB of data? All right, so for my Nokia 1100, do you think like 1 GB is something like beyond its capability? All right, so for this 1 GB can be huge for this Nokia 1100. Now let's take some other example. So I have a laptop fully loaded. All right, I have i7 processor. All right, 32 GB of RAM and 5 terabyte of hard disk. So do you think processing 1 GB of data with my laptop, do you think it's a big task? Do you think it's a big task? No. Right, for my laptop, this 1 GB data is not a big data. Right, for my Nokia 1100, it's going to be a big data. So guys, it's not about your data volume always. Of course, data volume is also one of the major consideration, but it's not about the data volume. You can define your big data something like this. If something is beyond your processing capability or beyond your technology capability, then we're gonna use a term called big data. So big data is just a terminology used in the industry, guys. There is no technology called big data. It's just a terminology used in industry. Whenever something is beyond your traditional processing system, then I'm going to refer them as a, oh, we got a big data issue. So definitely what you can say that it is just a problem statement. It is just a problem statement. So definitely big data is nothing but a problem statement. So now if you have some problem, guys, definitely you're going to have some solution, right? Definitely if you have some problem, definitely you're going to look for some solution, right? So let's say that I bought my iPhone 10. iPhone 10. So can I say iPhone 10 can process this 1 GB data very easily? Yep, without any without any problem. Yes. So can I say one iPhone X is nothing but one of my probable solution? All right, wonderful. All right, I have another solution called Samsung Note 8. So Samsung Note 8 also one of the solution, can I say? So these are nothing but my solutions. Right. So this is nothing but big data is nothing but a problem statement. All right. iPhone 10X and Samsung Note 8 is nothing but a solution. Now instead of Nokia 1100, let's talk in a technology terms. All right. Now let's say that I have a RDBMS here. I have a RDBMS here or any data warehouse system. And instead of 1 GB, I have like 100 petabyte of data. So do you think this 100 petabyte of data you can easily process with RDBMS and data warehouse system? I think yes. No way. Right. It's going to be very difficult, guys. All right. Very, very difficult. Almost close to. All right. It's going to be very difficult across your traditional system. Am I right? So can I say 100 petabyte is something beyond my RDBMS or data warehouse capability? All right. So can I say we got a big data issue? All right. So definitely you need to have one of the solution, right? So let's say that I got Hadoop here. Hadoop is one of the solution. All right. At this point of time, you can say that big data is nothing but a problem statement and Hadoop is nothing but a solution. Now let's take this challenge. So let me give you let's assume that I have given you this huge amount of data. Right, 100 petabyte of data I've given to you, and I've asked you to do some business intelligence out of it. I've asked you to perform some analytics or calculation out of it. So what is the major challenge you're gonna get it, guys, if I present you this 100 petabyte of data? Can you guys think? What is the challenges you're gonna face if I give you this 100 petabyte of data? All right. So guys, one of the challenge, can all agree, guys? How I'm gonna store this huge, massive amount of data? So storage is one of the challenge. Very good, Shilpi. And the other challenge here is, the major challenge is how I'm going to process it. I'm going to make a query on top of it. So processing is another challenge you're going to get it. These are the two huge challenges you're going to get it if I have a huge amount of data. All right. Rest of the stuff is also challenge, but this is kind of like major challenge. Am I right? Can you say yes, no, maybe? Yes. So anytime if you have like huge amount of data, humongous amount volume of data, the two challenges you're gonna get it, like how I'm gonna store this and how I'm gonna process this huge amount of data. Okay. So now let's understand about the data life cycle, guys. So here in this, we're going to discuss like what are technologies involved with big data, what are their purposes, and how they're gonna sit in your data lifecycle management or any software lifecycle management. So after having this discussion, you will get a complete idea about like what are different Hadoop ecosystem technologies and what are their purposes and how they are related to each other. All right. After this, like probably like 1 hour, you will be able to talk in Hadoop. All right. So imagine that your data is coming from multiple data source. Imagine that your data is coming from multiple data sources. So data source 1, data source 2, data source 3. So imagine that your data is coming from data source 1, data source 2, data source 3. So part of my data is there in my data source 1, part of my data is there in data source 2, part of my data is there in data source 3. Okay, now I want to make some analytics on top of my data. So I have some partial data set across data set 1, data set 2, data set 3, which has been stored. Now I want to make a calculation or I want to make some analytics on top of my data. Will I able to perform my analytics on top of this individual machines or on top of this partial data set? Golden rule of analytics, guys. Can I able to perform my calculation on top of this partial data sets? All right, you can do it, but it's not. Right, imagine that, for example, if you want to make some analytics, let's say that I want to find out Sachin Tendulkar's international centuries. Now, if Australia and England data set is missing, will you able to talk about like Sachin Tendulkar's international centuries? All right, definitely, definitely you're gonna get the wrong answer, wrong indicators, wrong values. So golden rule of analytics, can I say I have to apply on top of my entire data? Any analytics or any calculation if I want to make, I have to apply on top of entire data. Am I right? Yes, yes, no, maybe. All right, good, wonderful. So guys, basically the first step is gonna be, right, so since I cannot apply my logic on top of my partial data set, definitely what I have to do here is I have to have some tools to capture my data from, right, various sources. I need to have some tool. So the first phase of my data lifecycle management is capturing. So I need to have some technology which can capture my data. Wonderful. So once my data has been captured, guys, once my data has been captured, what I have to do, guys? So I've captured my data from various data sources. Now the next step is I have to store this data. I have to store this huge amount of data. All right. So if I want to store any data, guys, what is needed? If I want to store my data, what is needed, guys? Sudhanshu, Suman, Vishwajit. What is needed, guys, if I want to store any data? So can I say some storage, some hard disk, or altogether can I give a generic name called file system? Or I require some operating system or some file system to store this data? Yep, some file system. Wonderful. So can I say like one operating system or one file system is enough to store this humongous amount of data, 100 petabyte of data? Can I say one file system is enough to store this huge amount of data? No, right? So can we add one extra D over here? D stands for distributed file system. So I need multiple file system to store this huge amount of data. All right. So somehow at this point of time, I'm not worried like how it will storing your data across like multiple computer as a single unit. All right. So that is a distributed file system concept. But at this point of time, just imagine that your data is being stored across your distributed file system somehow. Wonderful. Now, once I store my data into HDFS, what is my next task, guys? What is next task? What is our bread and butter? What is our bread and butter, guys? All right. So capturing is nothing but, all right, tools. All right. These are nothing but a softwares. All right. This is nothing but with the help of some software, I'm grabbing my data from one place to another place. Got it, Pankaj? So it's gonna store your data into DFS. So guys, can I say the major important thing what I have to do here is processing, making some analytics, making some calculation, making some business intelligence, right? So that is nothing but in the processing layer, right? So if I want to make some calculation, guys, definitely this guy needs to, if this guy wants to write a logic, guys, definitely he has to know about some programming language, right? Some programming language knowledge is required, right? With the help of this APIs, this guy can develop a logic or job. And this job going to be executed on top of your distributed file system. So basically, in the processing layer, I may need some programming language. With the help of this, I can write my code. The code I can execute on top of my distributed file system. Right? Okay, wonderful. Now, if I run any job, guys, what I'm gonna get it? Let's say that I've run a Java job. What I'm gonna get in turn? What I'm gonna get in turn? If I run any job, all right, we're gonna get some output. Am I right? So those output I don't want to see in numbers nowadays. All right, so we all now grown up now to see our data in graphical way. Right, something like this chart representation, peak chart, something like pie chart, something like density representation, something like this. I want to have like this chart support. All right. So if you want to integrate with your result with this chart, What is the technology you have to integrate with, guys? What is the technology you have to integrate with? Question. Wonderful. Can I say some of the reporting tools? All right, any reporting tools I need to integrate with? Wonderful. Can you give me some example of my reporting tools like Tableau, right? Spotfire, right? Power BI. Like that, you have so many options. All right. So imagine that whatever the data I process, I want to process further with my traditional systems, like my traditional ETLs. All right, I want to integrate with my traditional ETLs so that like I can further process my data using this current ETL. So can you give some popular ETL tools? The most popular, Informatica, you have Abnisio, you have Talent, all right, you have so many other technologies ETL tool available. So I can integrate with my current ETL as well. That's great. So these are the layers involved in software data lifecycle management. Out of which, guys, if I have a huge amount of data, what are the layers which got impacted? Out of this, if I have huge amount of data, what are the layers which get impacted? Just now we have discussed that. What are the layers which got impacted? Majorly. Majorly, guys, what are the layers? Can I say storage and processing? Am I right? So these are the two layers which got impacted if I have this huge amount of data. All agreed with my answer? Yep. Quick response from everybody, guys. Ankit, Balaji, Bishwajit, Vikramjit, Suman, Sudhanshu. Cool. So guys, so definitely if you have a problem statement, definitely you need to have some solution, right? So you got a solution called Mr. Hadoop. You got a solution called Mr. Hadoop. So Hadoop is nothing but an implementation of your storage layer and processing layer. So basically it's a software framework which provides the implementation of your storage layer and processing layer. For storage layer, it has given a technology called HDFS. Or it has given a file system called HDFS. So HDFS stands for Hadoop Distributed File System. All right. For processing, they have given a programming language called MapReduce. All right. So can I say Hadoop is nothing but two major core components, HDFS plus MapReduce? Which Hadoop comprises with two components. For storage, it's Hadoop Distributed File System. For processing, we got MapReduce. Wonderful. All right. So this MapReduce is typically written in Java. This MapReduce is typically written in Java. All right. To learn this MapReduce, you require to have that prerequisite. All right, that prerequisite. So entire MapReduce API is written in Java API. So in order to write a MapReduce processing code, you need to have little Java knowledge. I can say like little core Java knowledge or all those 5 chapters. If you can do it by yourself, you can make things very easily. But apart from like if you're a non-Java developer and if you're like mostly from a SQL background, you got a tool called Hive. So Hive is one of the alternative to write a MapReduce job. So basically, instead of writing your code in Java, you are writing your code in a SQL style language, SQL-like language. In the background, this Hive tool is converting things into a MapReduce job. All right. All right. Hive will be converting your SQL data into equivalent MapReduce job, and this MapReduce job again executed on top of your HDFS. So I can say it's a high-level abstraction language or it's a translator kind of stuff. Because bottom line, all your job gonna be run in top of MapReduce, or indirectly it is gonna create a MapReduce job. Then you have Pig. So Pig is high-level abstraction language. Again, instead of writing a SQL-like language, you're gonna write your code in a simple English-like language. Simple scripting-like language, you're gonna write your code, and this code will be executed on top of your. All right, so you're going to write your code in a scripting like language, and this code going to be executed on top of your HDFS. So all your Pig job also be converting into a MapReduce job, and this job going to be executed on top of HDFS. So these are two nothing but alternative high-level abstraction to write a MapReduce job. Now, if you observe that in MapReduce, I'm processing my data over disk. Am I right? All right. I'm processing my data over a disk. If I'm processing my data over a disk, I can use a term called IO-based processing. Now, what I want here is I want to process my data very fast. All right, I want to process my data real quick. All right, which computer hardware will give you which computer hardware will give you maximum like fastest processing, guys? Which computer hardware will give you a fastest processing, guys, in general? Can I say memory? Right, memory is the fastest place to run your job. Am I right? So now if I have a requirement to process my data little fast, or like I want to have like lightning fast queries, if I want to make it, then I can use a tool called Spark. Right? So Spark is just like MapReduce. Spark is another processing technology. With the help of this, I can process my data on top of my memory. So anytime if I want to process my data, like I want to have like real fast analytics, I can push my data into my memory, and definitely I can process my data from there. So definitely as compared to MapReduce, will be the Spark, it's going to be lightning fast, guys. Spark going to be lightning fast as I'm loading my data into memory and processing my data over there as compared to processing my data over disk. So Spark, I can use a term called in-memory computation engine. In-memory computation engine. Super. Right. Now let's understand about the other component, guys. So imagine that this data source one is RDBMS. All right. This data source two is, imagine that some application server. This data source is, imagine that some XYZ server. All right. So the first and foremost stuff, you need to have an interface which can capture your data from your source and push your data into your destination. So you need to have some tool. All right. The most important tool, guys, whenever you want to deal with any RDBMS blindly, you can go with a tool called Scoop. And the Scoop derived from a word called SQL to Hadoop. And what they have done here is they made a technology name called Scoop. All right. So anytime if you want to capture your data from RDBMS to HDFS, blindly you can go with a tool called Scoop. Scoop is one of the data capturing tool which will help you to store your data into HDFS from RDBMS. All right. It supports two major operations, guys. All right. You can either import your data, so you can get your data from RDBMS to HDFS, and the vice versa is also possible. So you can export your data as well. So now the next example is application server. So imagine that I want to deal with streaming data. What do you mean by streaming data, guys? What do you mean by streaming data? All right, wonderful. Wonderful, guys. So can I say streaming data is nothing but a moving data or a real-time data or a live data? Am I right? All right, wonderful. So now let's assume that I have hosted a Twitter server. So I have hosted Twitter application inside my application server. So now this Twitter will generate streaming of tweets. So can I say Twitter is nothing but one of the streaming source? Will it generate moving data, guys? Am I right? All right, your Facebook, your Twitter, it's going to generate a continuous data. All right. Now, if I want to deal with this moving data, guys, if I want to deal with this moving data, I can use a tool called Flu. All right. So inside this course, I'm going to help you to how to download your live tweets from a live Twitter system, how to form a connection and how to load your data into HDFS in a streaming fashion. I'll show you live. Guys, if it is XYZ, guys, all right, I can create my own source and destination using Java HDFS API as well. All right, so these are kind of like my different data loading or data ingestion technique. All right. So guys, what is my ETL here? I got the question. What is my ETL here? So the entire process, can I call it as ETL, guys? All right, I'm trying to extract using capturing. All right, so I'm storing my data in HDFS and performing transformation using Hive Pig. So can I say entire process is nothing but my ETL? Got it, Pavan? All right, instead of yeah, you can call it as ELT. Yeah, you can call it as ELT as well. All right, wonderful. So now if somebody asks you what are my data loading techniques, what could be the answer, guys? Informatica is another ETL tool. It's altogether a different ETL tool. All right. I can integrate finally on top of ETL. Whatever the process result is, I can further. Meanwhile, guys, if you have any, all right, answer my question, guys. What are my data loading techniques? Can you list it out? Go ahead. You can speak now. Right.
Are you able to hear me?
Yeah.
Yeah, I just said that, like you mentioned here, that ETL Informatica Avenue talent actually. That
Hmm.
actually I got confused. I understood like you are loading data using Scoop, Flume, and whatever, and getting into HDFS. Then you are using MapReduce,
No, no, no. Don't explain what I taught you. Like, what is your doubt?
Yeah,
Doubt
I
is
my only
ETL.
doubt is there is a diagram where you are mentioned Informatica ab initio talent. Why that was mentioned? That part I did not. I missed out. I
Okay,
think.
I already informed in the class. Can I say it's a different ETL tool? With my Hadoop system, can I integrate with any of my ETL? Yes, everybody? Okay, wonderful. Did you get it now? This is a different ETL tool. I can integrate with my Hadoop ETL as well.
Okay.
All right. So, guys, you can type most of the questions, guys. All right. If you're not able to express, then you can use the call button. Very clear explanation. Wonderful. You're awesome. Thank you. Thank you, guys. So now let's imagine that. All right. So here we are not talking about the performance. Here we're just talking about like we have not started itself. Like we're just talking about like what are the technologies involved. So don't worry about it. We're gonna have like detailed discussion among all of these topics. All right. Now let me introduce one more technology, guys. All right. So imagine that I have a file called pavan.txt file. And what I want to do here is I want to read one line. All right. If I say my HDFS offers sequential data access, what does it mean? All right. What does it mean, guys? If somebody say that HDFS does have a sequential data access? Wonderful. So can I say if I want to read my data, I have to read my data line by line? If I want to read my data, I have to read my data entire line by line. Complete file I have to read, and then I have to extract whatever stuff is needed. Am I right? All right, so that is sequential data access. Now, on top of, imagine that I have RDBMS. All right, in RDBMS, if I want to access any record, guys, what could be the access pattern? What could be the access pattern? So can I say random access rather? I can randomly access with the help of any key. Am I right? So I don't need to access entire, I don't need to scan my entire stuff. I can access my key with the help of my ID. Wonderful. All right. Now, like Hadoop, you're getting a sequential data access. Now, what technologists thought like, why can't we have random access capability on top of my HDFS? That's where they have designed a tool called NoSQL database. Right, the prime purpose of NoSQL database is they want to achieve random access. There are many other reasons as well, but why they thought of creating this NoSQL database is they want to achieve random access capability on top of like big data environment. So if you want to have a random access capability, guys, you can use on top of your big data if you want to use, because by default you're going to get a sequential data access. Anytime if you want to do a random access need, you can go for NoSQL database. So guys, can you list some of NoSQL database, guys? Can you list out some of the NoSQL database which you have heard about it? All right. So which we gonna learn? We're gonna learn HBase. Wonderful. All right. All right. I see in your batch like nobody has given MongoDB. Like in most of the batch, people will tend to write instead of Mongo, people tend to write Mango. All right. So here in this batch, no problem. I I think like everybody's intelligent here. So MongoDB is another database. You have MemcacheDB, you have TerraStore, you have Zones, you have Neo4j, you have so many 50 plus NoSQL database. So here in this module, we're going to learn about like one of the NoSQL database called HBase. Now let me introduce one more technology here. So I have plenty of technology which is supporting my Hadoop like Hive, Pig, Scoop, Flume. So imagine that I want to create a flow. So I want to run my job 1, job 2, job 3, job 4, job 5, job 6. Will you say your client you can run job 1, then run job 2, then run job 3? Can you say something to your client like this? Right, run job 1. After once it's finished, run job 2. If it is finished, run job 3. No, right? It will kill you. So what I have to do, guys? Do I have a requirement to create a control sequence or a workflow of all this job? Yes. And those workflow, I need to schedule it. So basically, you need to have some scheduler who can run my job in a sequential fashion or who can run my workflow. So have you guys heard about term called control M, autosys, cron job? Have you heard about it? Control M, autosys, cron job. Yes. All right. What are those, guys? Can I say they are nothing but a scheduler, workflow schedulers? Wonderful. All right. So now Uzi is the workflow scheduler for a big data environment. All right. Uzi is nothing but a job scheduler, which is there for big data environment. Wonderful. Okay. So now, all right, you have another technology which is kind of like act as a coordinator. So we're going to discuss this in detail. Just imagine that Zookeeper at this point of time, it's nothing but a separate cluster. What it's going to do here is it's going to coordinate all your coordinate with different applications. All right. So basically top level. All right. If something goes down, it's going to redirect to other application. If something goes right, it's going to redirect to a particular server. So at this point of time, just imagine that Zookeeper is a coordinator system, which we're going to discuss in detail. All right. So apart from that, you got all your Uzi, all your Hadoop component over here listed. Now everybody got the complete picture about like all the big data technologies. Now everybody able to talk in Hadoop as well, like what are their purposes and where exactly in which layer it's going to be used. Yes, no, maybe. Cool. All right. So now with this knowledge, let's start our discussion with our first slide. Okay. So guys, understand what is big data. I've just explained everything. So can I say big data? All right. It's not only about the volume. It's about like variety of other parameters as well. So we're going to discuss those as well. But definitely, guys, if I get a huge amount of data, definitely whatever the current system I have, right, it will not have a capability to handle this data. So basically, you're going to get a storage and processing issues, right? These are the two major challenges I'm going to get it. You can see the example. Reddit user cast 18,327 votes. All right, Reddit is a website which is going to maintain kind of like huge amount of data set. All right. The final project we're going to do on the Reddit data set itself. Right. So you have a Twitter. Twitter is also generating kind of like huge amount of data. Facebook, enormous amount of data. Instagram, enormous amount of data. YouTube, almost like you can say that every minute per day, user uploads almost like 300 hours of new videos. All right. So now you're getting your data from a smartphones, you're getting your data from a cloud services, you are getting your data from YouTube, you're getting your data from Twitter, you're getting data from Flipkart. So basically, so many, like everything is become digitalized. Now, everything, if I want to maintain, I need to have like some system which will give you a capability of unlimited storage and unlimited processing. Right? So we are looking for a solution for this huge data explosion. All right. Not only this data explosion, guys, the main problem here is you have different types of data. All right. So you have three types of data, be it be structured data, be it be semi-structured data, be it be unstructured data. You have three types of data: structured data, semi, unstructured. What is structured data, guys? What is structured data? Anything which is in the form of rows and columns. Can I say it's structured? So I can access it very easily. From childhood, we are accessing RDBMS. But if I want to access what is semi-structured data, can you give me some example of semi-structured data? Can you give me some example of semi-structured data? All right, so it can be XML, JSON, wonderful. So basically, this semi-structured data does have some structure, but it does not have data arranged in a rows and columns. So that is the reason we can call it as semi-structured data. I can still process semi-structured data, but what about unstructured data, guys? What about unstructured data? Right. So do you have any technology which can directly work on top of unstructured data? No. Right. If I want to work out with unstructured data, I have to convert them into a structured format or semi-structured format, then we used to process it. So that is the challenge. And now you can see this graph, you can see that the rate of unstructured data is growing. It's huge. It's huge, guys. Right, most of the data you're getting from like web nowadays, it's unstructured data. Now, if I want to deal with unstructured data, no proper technology available. Now, what if I say that Hadoop is a technology which can process not only unstructured data, it can process structure and semi-structure as well. So basically, all type of data my Hadoop can handle. This is one of the key feature. You're gonna get it with Hadoop. All right. So you have some facts on your screen. By 2020, International Data Corporation predicts the number will reach to 40,000 exabyte of data. So which is almost close to 40,000 zettabyte of data. And as a matter of the fact, the world information doubling every 2 years. So by 2020, you can expect all the user does have like 5,200 GB of data. On the average, you're gonna get a particular person is holding that much data. Okay, so now let's take a break, guys. Once we come back from the break, we're gonna discuss about this properties. Right. So let's take a break of 15 minutes. Once we come back, we're gonna do rest of the stuff, guys. So golden rule, while we are on break, guys, once you come back, you have to type a letter called back. You have to type a word called back so that I'll get to know that you guys are back. And please be back on time. All right? Cool. I hope everybody able to follow the session till now. Yes, no, maybe anyone not able to understand? Yeah, it's 15 minutes break, 9:35 to 10, 9:35 to 9:50. Cool. Almost like 8 guys responded. Very good pace and explanation. Your explanation is very good. Cool. Thank you. All right, let's meet back after 15 minutes. Hey guys, I'm back. Now let's understand about the different types of data. All right, imagine that you're a solution architect and you want to pick a technology now. Okay, so on what basis you're going to pick a technology? All right, you can define your big data with this three V's property. You have other V's also. The first V is volume. Second V is variety. Third V is velocity. All right. Imagine that I have 1 GB of data. All right. Will you go for big data? Will you go for Hadoop? Or the volume is nothing but a size of data. So if I have 1 GB of data, will you go for Hadoop, guys? What technology I'm gonna go with? Can I say regular RDBMS? Yep. All right. Now let's say that I have 100 petabyte of data. What could be my choice, guys? What is the technology I'm gonna opt? All right, I can opt Hadoop. Wonderful. So now let's say that I have a variety. Variety is structured data. Variety is nothing but a type of data. So if I have structured data, guys, what is the best choice? Which technology is the best if I want to deal with structured data? Of course, your SQL and RDBMS, you can say that. But now let's imagine that I have a structured data, but I have a volume of 100 petabyte of data. So what technology I have to opt with? I have a structured data, but it is 100 petabyte of data. Again, I have to go with Hadoop. Now let's say that I have unstructured data. Do you have any choice? Which technology I have to go with? Which technology I have to go with? If I have unstructured data, blindly can I go with Hadoop? Wonderful. All right, then you have a velocity. Velocity is nothing but the rate at which data is hitting your data sources. All right. So the speed, all right, the speed at which data is hitting your data sources. So if your velocity of your data is more, all right, if your data is coming with very huge velocity, which technology I can go with? I can go with Hadoop, right? So this based upon three V's property, you can decide on like how you're gonna opt for technologies. Now another way to define, guys, let's say that you got some information you have downloaded from the internet. So if you download anything from the internet, is there any guarantee that whatever the information you have downloaded from the internet is 100% correct? Whatever the downloaded information is 100% correct? Yes? No? All right. So if you have downloaded some data from the internet, will it, like, can you assure that like all my data is 100% correct? No. All right. Now, what is the problem you're going to get it? If I perform my analytics on top of this incorrect data, will I get incorrect analytics or will it show me a wrong indicators which gonna which gonna hamper my businesses, like which this analytics gonna hamper my business? Yes. So If I apply my logic on top of my wrong data set, it's going to give me wrong analytics or wrong indicator, and that's going to be harmful for my business. So now what I have here is I have another property, sub-property you can say, called veracity. Veracity is nothing but finding out correctness of data. Finding out, it's nothing but making analysis to find out correctness of data. So I'm going to make some analysis on top of this data. Some calculation I'm going to make it on top of this data to find out the correctness of data. So after finding out this analytics, if I find that 50% of my data is incorrect, will you perform your analytics further on top of this data, guys? Or will you leave this data? Will you leave this data if I have like 50% of data which is value is incorrect? Yes, you're gonna avoid it. Now if you got like if you made analytics and you find it out like 94% of data is absolutely accurate. Now I can perform an analytics on top of it. All right. So guys, after performing an analytics, whatever the result or whatever the values I'm getting here is, that is nothing but my value. After analytics, whatever the result I'm getting, that is nothing but value. Those value is going to be helpful to make your like to be used as a business intelligence. So these are the kind of like you can consider this 5 V's property, but out of which, what is the most important, guys? Volume, variety, and velocity. All right. So now let me introduce a beautiful lady. Her name is Annie. She's going to ask a lot of quizzes in between. All right. So you have to answer her questions. So now the first question in your screen, map the following to a corresponding data type. So you have to specify in one single line. You can specify the first one is unstructured, second one is semi, SEMI, UNST, or STR. Like that, you can specify in one single line. Vikramjit, can you check your answer? Vikramjit, can you check your answer? All right, almost like everybody gave the correct answer. All right, so can I call it as XML semi-structured data, audio, video, unstructured data, and data from enterprise system, any ERP is RDBMS, so structured data. Wonderful. All right. So now you have some further reading slides. So you can take it like whenever you have some time. So we have created some blocks, information. So you can read on more on big data, why Hadoop, opportunities in Hadoop, IBM 5V's property. All this you have like well documented blocks are available. So you can spend some time over there. So now let's discuss some about the use cases, guys. Anybody working in any e-commerce based company, guys? Anybody working in an e-commerce based company? So guys, can everybody type your domain, which domain you guys are working? Which domain you guys are working? So yeah, Pankaj, I know telecom. What about others, guys? Oh, Ankit is working in retail. BFS, Santosh, okay. Banking and financial services. PHP, retail and insurance. Okay, cool. Cool. So you have like bunch of different domain people available here. Cool. Guys, if you're a e-commerce based company, guys, right? So Amazon, like let's say that you're working in eBay, Flipkart, Amazon, Alibaba. So if you're working in this company, so what are the common analytics you can think about it, guys? What are the common analytics you can think about it? So the first thing I can think about, like most important part, I can think about like, all right, recommendation engine. So what do you mean by recommendation engine? What do you mean by recommendation engine? All right, wonderful. So based upon my previous custom history, based upon previous buying pattern, can I suggest some of my product to my customer? Can I suggest some of the product to my customer? Right? So that is like you, like if you go to Amazon, right, when you're buying any product, you're getting some recommendation, like people who have purchased this, they bought this together. So how you're getting it? So internally they made some analytics and they made some recommendation models. So one more stuff, ad targeting, guys. Right. One more stuff, ad targeting. So guys, I want to sell my course. So do you send advertisement to 100 years old guy? I want to sell my Hadoop course. If I send my advertisement to 100 years old guy, will it make sense? Or if I send my Hadoop course to a doctor, will that make any sense? Will my sales gonna be increase? All right. So basically, all right, I have to target appropriate audience based upon like what he has searched, all right, on the eBay or Flipkart. I have to give proper advertisement. And again, like search quality is the prime criteria. Abuse and click fraud detection in the reviews. If you can see a lot of abuse, right, you can take an action on top of it. All right. So now you are a telecom guy. So one of the guys from telecom domain. Right. What is the common analytics you can think about it if you are from a telecom domain? What is the common analytics you can think about it if you are from telecom domain? All right, wonderful. So I got plenty of analytics. Can I say out of which one of the major stuff, guys? Can I say customer call data record analysis, CDR analysis? Yes. CDR analysis? Yes. Okay. So, guys, for example, let me give you a scenario. A person is calling. I have a data set where I found that a person is calling to the other part, like other party. All right, every 2 seconds. Every 2 seconds, these guys are talking, and the call they are finishing in 2 seconds, and they're continuously calling for 15 times. So if I found this type of analytics, what does it mean, guys? What does it mean? What I can make out from here? So can I say there are frequent call failures? So there is no way that a person will talk for 2 seconds every minute? No, right? So that means there is frequent call disconnects. I can make this type of analytics. And one of the important nowadays, the moment you got a number portability, all right, the attrition ratio is increase. So customer churn prevention, customer attrition is one of the key analytics. So I want to prevent my customer. So let's say that I have a customer call center data available, and I found that this customer is very irate. So in order to retain this customer, what I'm going to do here is I'm going to generate some offer, right? Let's say that you can use 10 GB of data from 12 to 5, 12 p.m. to 5 a.m. You can use 10 GB of data. So I can generate some of the useless offer to my users in order to retain the customers. Am I right? All right, these are the things I can make it. So in order to retain my customer, so customer prevention is also one of the stuff. Network performance optimization. All right. So I have to check it on like how much is a load on weekdays, how much is a load on weekends. All right. Is my customers getting or like are they able to make a perfect calls? Is there any disruption, and disturbance or call disconnect? All this thing, I can find it out. I can analyze on network and predicting failure. I can make log analysis and a lot of stuff. As a telecom developer, I can do it. All right. So everybody, where are you guys located? Where are you guys located? Everybody. So Pankaj from Bangalore. Oh, Vikram from Mohali. Okay, cool. All right, Santosh from Phoenix. Pavan from US. All right, Bishwajit, Kolkata. Yeah, I can make it out easily. Bishwajit Ganguly, Saurav Ganguly, Kolkata. Yeah, cool, cool. So everybody knows Aadhaar, right? All right, I can see all Indian names, so everybody knows Aadhaar. Okay, so if you're from different country also, but still you know about Aadhaar. So Aadhaar is one of the government project, and if you don't know about Aadhaar, anybody, so it's nothing but a social security number of India. So every citizen gonna get kind of like unique authentication authorization number. All right. So if I have like Aadhaar card, when you're when you applied for Aadhaar card, did you give complete fingerprint scan, retina scan, and your place of birth, your siblings, all those information? Yes. Can I say Aadhaar maintains every all Indian citizen data sets? All right. Now, based upon those Aadhaar data set, guys, I can launch some of the welfare schemes. So imagine that I have a village and I found that all right, between the age group of 12 to 20, there are almost like 65% people living there. I made I made an analytics. All right, I made an analytics and I find it out that 65% of people are between age group of this and this. Now, once I get this information, guys, can I, as a government, can I form a school over there? Can I form a school over there? Government school over there? Yes. Government high schools, I can plan for government high school. So more example, let's say that I find it out after my analytics, I find out that some 30% of youth does not have like proper job resources. So as a government, like I can introduce some of the jobs to them, all right, to improve the employment services. Justice, I can make some justice as well. All right, let's say that a river is flowing from one state to another state. So now the water has to be shared. So I cannot share like water 50-50%. No, right? So government has to decide how many people are living in both state, how many people are consuming that water, both state, how many lands of water, like how many hectares of water is needed for irrigation in both the state and other parameters. Based upon that, it needs to come up with okay, state one has to get some hectares of water, or state two has to get some hectares of water. All right. So I can do justice as well. And if it is healthcare sciences, guys, all right, a lot of development going with healthcare science. You can do gene sequencing, you can serialize your data, you can plan for drug safety measures, you can do a lot of scientific analytics on top of like healthcare data as well. So let's say that you're a banker. So one of the guys working in a banking domain. So if you're in bank, guys, what are the what are the key common analytics you can make it, or you can think about it? Right? Anti-money laundry, wonderful. All right. So guys, just like a civil scoring, guys, just like a civil scoring, right? Internally, bank also maintain some scoring to allocate some, all right, based upon certain parameter, they're gonna give you some numbers. All right, based upon that, they're gonna offer some pre-approved loans or predefined loans. And let's say that on the scale of 10, all right, based upon my previous spending history, based upon previous financial commitments, and how I'm handling all the previous historical data, all right, they're gonna make or give some points to me. So if I have like 9 points, they can offer me up to crore, 1 crore personal loan. All right, if I have like point between the range of 6 to 7, they're gonna offer 20 lakhs, something like this. So credit scoring and analysis, I can make it with any banking stuff. So most of the banking does have their financial stuff, all right? So most of the banks invested money in stocks, so trade surveillance, trade analysis, they can make it on top of it. All right, investment bankers, they can help me too. invest on proper stocks and all. Fraud detection. So I can detect any fraud if anybody trying to make some fraud with bank. Threat analysis. All right, I can model to risk. These are the kind of like stuff analytics you can make it if you are from a banking domain. Now let's say that you are working in retail. Imagine that your product is there worldwide. Worldwide, you have your product. All right. And what you want to do here is you want to make some analytics on top of like entire world how your product is doing. All right. So let's say that I want to find out point of sales transaction analysis, right? In which country I'm doing good, which country I'm doing bad, which country I have to do a lot of development, what are the local sentiment about my product, or what are the changes I can plan, all right, in my next release. All this stuff I can make it. And of course, in retail, the most important here is customer attrition prevention. All right. So hope everybody knows about Sears. People who are in US or Canada, they know about Sears. Yes. All right. Sears is one of the retail company, guys. Now it is close to bankrupt. That is the other case. All right. So I've asked them to remove this slide. So Sears is one of the company. Earlier they were using Teradata, Oracle Exadata, and SAS. All right. They were not able to do much thing. They were not able to make a kind of like very impact analytics. They are not able to make more precise analysis with more data coming every day. All right. So they want to have some key early indicators or key early analytics to change their fortunes. All right. So then they move to Hadoop. All their analytics related problem has been solved. Earlier they have tried Teradata, Oracle Exadata, SAS, but still they're not able to do it. With the Hadoop, they're able to store and process this huge amount of data. Now let's understand what is distributed file system, and then we're going to learn what are the different distributed file system available. So imagine that, guys, I have multiple computers available. I have multiple computers available, multiple computers available. Imagine that I have 100 computers available. All right, I have one, two, three, like that, 100 computers available. All right. So with the help of this distributed file system, now imagine that I have a computer capability. I have 100 computer altogether. I have 100 computer, right? Each computer, each computer does have RAM as 16 GB, storage is 1 terabyte, or all right, and all these computers are nothing but a quad core processor. All right. Now, with the help of distributed file system, what is this distributed file system? So distributed file system is nothing but a piece of software. So distributed file system is nothing but a piece of software. All right. What it does, what it does, it enable all this 100 computer which going to act as a single coherent system. So for this user, all right, this guy will not see all 100 computers. Rather than he will see only one single computer. So the distributed file system is a piece of software that enable all its 100 computer or enable all its computer to looks to their client as a single coherent system. Single coherent system or a single system you can call. So now this guy will see how much distributed RAM, guys. You can answer this. This guy will see how much of distributed RAM. Okay. So how much distributed RAM, guys? I have 16 GB in each computer. So can I say 1600 GB? So how much of distributed storage I'm gonna get it? How much of distributed storage I'm gonna get it? All right, 100 terabyte. So, all right, it's very simple, right? So this guy will not see 100 individual computer. If it is distributed file system, it's gonna act as a single system, though you have multiple computer underneath it. Now you have to understand one of the very important stuff called types of distributed file system. Right? So you have like type of not NoSQL database, it's type of DFS, distributed file system. All right, so now you have like one of the approach called available called computation intensive. This is very important, guys. Computation intensive. Okay, so what is this computational intensive? Right. So what is like imagine that this guy, what is the main purpose of this guy? This guy wants to write a job. This guy have successfully written a job. Now imagine that I have my data stored in distributed file system. All right. So somehow my data is stored in distributed file system. All my 100 terabyte of data is stored in storage units. Now, if I want to process my data, guys, in this computation intensive approach, what we are trying to do here is we are maintaining separate processing unit. We are maintaining separate processing unit. So I may have like computers, right, for my processing as well. So I can maintain a separate processing unit in this approach. Right. So if I want to process my data, guys, I need to upload this 100 terabyte of data into my processing units. Over the network, I have to move this 100 terabyte of worth of data or whatever is, I have to move it across my processing unit. And then I can process my job, right? Over here, I can process this 100 terabyte of data here inside my processing unit. Definitely, if I run this job, I will get some output, right? Imagine that I got 50 terabyte of output. Again, this 50 terabyte of data, I have to store it into my distributed file system, something like this. Now with this, like what are the challenges you're seeing with this approach, guys? What are the challenges you're seeing with this approach? What are the challenges you're seeing with this approach? Space, no. Can I say time to upload and download my data? It's going to be very high. Can I say there is a lot of network traffic involved? Right? Can I say a lot of network traffic involved? So if lot of network traffic involved, so let's say that you are in Bangalore, will you able to reach on time? Network traffic involved. Anyone Bangalorean can understand the pain. So lot of network traffic involved. All right. So you can see that time to upload your data, time to download your data itself gonna high. So now let's imagine that time to upload my data is 2 hours, time to download my data is 1 hour. So almost like 3 hours is wasted only to upload and download. Right? I didn't calculate my processing time itself. So there is a lot of network traffic involved, and moreover, moreover, can I say, all right, it's going to be expensive. I'm maintaining separate processing unit. So it's going to be expensive processing unit. I have to buy it if I want to make this. Guys, so can I use a line, a word, moving data near to processing unit? Can I call it as computational intensive? Yes. Moving data near to the processing unit, can I call computation intensive? Yep, yes, no, maybe. Guys, energy, where is the energy? All right, I have moved my data. Guys, I've just now show you. Move my data from storage unit to processing unit for the further processing. So can I say moving data near to processing unit? Can I say yes? It's a computation intensive. Just now you have learned. Cool. Wonderful. All right. Now, do you think Hadoop gonna use this approach? Do you think Hadoop gonna use this approach? No. Hadoop does have a better approach called data intensive approach. All right. Data intensive approach. Okay. So what I'm trying to do, guys, here also, this guy wants to write a job. This guy wants to write a job. All right. Here also, this guy wants to write a job. Now, here also I have a storage unit. Here also I have a storage unit. All right. So in my storage unit already I have my data. Wonderful. All right. So this is nothing but my storage unit. So in this approach, data intensive approach, guys, all right, I'm not maintaining any separate processing system. What intelligently I'm trying to do here is I'm making my storage and processing unit in a same computer. Storage and processing in a same computer. Okay. So my storage and processing is in the same computer. This you have to remember. Guys, in Hadoop related technology, all your storage and processing has to be in a same computer. Imagine that. All right. Now, intelligently, what I'm trying to do here is instead of moving this 100 terabyte of data, what could be the maximum size of my code? Few MB, right? So instead of moving 100 terabyte of data of code, I'm intelligently moving my code near to data. So I'm going to move my job over here wherever it's needed. And I'm going to process my data locally. So what is the advantage I'm going to get it, guys, with this approach? Everybody give a point. What is the advantage I'm going to get it with this approach? So almost close to very less network traffic. All right. So there is no time wasted in uploading and downloading. Am I maintaining expensive machines for my processing? So cost is reduced. Am I right? So now this type of approach can I call moving data near to code. Moving data near to code, or no, sorry, moving vice versa, guys. Can I say moving code near to data is, you can call it as data intensive approach, right? Can I call Santosh? All right. So imagine that, all right, human being, or imagine a human being. For your understanding, for your remembrance, you can take this example. So as a human being, right, if I am hungry, how I'm gonna eat? I'm gonna eat my from my hands. All right. So here my food is nothing but my data. Food is nothing but my data, and my mouth is nothing but my processing system. Guys, if I want to eat, am I moving my food from my hand to our processing system? What is this approach? I'm moving my hand to my mouth, right? So what is this processing system? Computation intensive or data intensive? Moving data near to the processing is computational intensive. So in Hadoop, guys, we are not human. We are tigers. All right. Do you think like tiger gonna eat from its hand or directly from the processing system? Directly from the mouth. So can we say we are tigers? All right. We are not using our hand. We are directly eating from our mouth. So I am moving my processing system near to the data rather than right. Everybody remember this? Cool. All right. So always remember, like in future classes, you're gonna see like Hadoop follows master-slave architecture. So always remember your storage slave and processing slave has to be in the same machine if I want to implement data intensive. Am I right? Can you guys make a note of this? Storage slave and processing slave has to be in the same machine. Cool. All right. So I got like few break requests. All right. Okay, we can have 5 minutes break. All fine with that? Can we have 5 minutes break as most of the people request? All right, cool. So let's take a 5 minutes break, and once we come back, we're gonna do rest of the stuff. All right. Don't worry too much about the schedule, Santosh. If needed, I can take extra classes also. Not a problem. Don't worry about it. All right. Sure. All right, guys. All right. Is the storage unit processing unit called a node? Yes. In a node, I'm keeping the storage unit that is nothing but a one physical computer. Pankaj, how it's gonna be same? How it's gonna be same? I'm moving my data in my first approach. Here I'm not moving my data. I'm keeping my processing in the same machine. All right. So I'm avoiding. We're gonna discuss that, Shilpi. All right, that is a part of the discussion. So take out from your mind about this master slave architecture. You're gonna learn in very detail. So here you guys learn everything in very detail. All right. So there's no question of like going top level. All right, guys. See you in another 5 minutes. Hey guys, I'm back. Right, hope everybody's back. All right. So please help to let me understand what are the things to be read in Java. So I've shown you the Java prerequisite part. Those are the topics you have to cover. It is already there in your LMS. All right. So you have Java prerequisite. All right. So we required all this stuff for MapReduce. All this stuff, Java stuff for MapReduce. So probably next week, I'm not sure, like you're gonna have class on 31st. So you're gonna have like plenty of time, you're gonna get it. So almost like 1 week, 1.5 week, you're gonna get it to complete. So I'm not sure whether it's decided or not. So 31st, one weekend is coming, right? Next weekend is coming on 31st, right? So I'm not sure whether you're gonna have like class on Sunday or not. All right, if it is there, please try to complete this week itself. But mostly, like according to historically, guys, 31st you're gonna get holiday. Every year it's gonna be holiday only. And nobody wants to learn on 31st night. All right, guys. So people who want 31st day class, you can raise your hands. You can say or holiday you can raise yes or no. All right, so most probably it's not yet decided. It's not yet decided, but like I've been associated with Edureka from past 5 years now. So every year we're gonna have holiday on 31st. Cool. All right, so that is the next week stuff. Don't worry about it. So next Saturday you have a class, and then we're gonna decide. Like let's leave it to Edureka. All right, if they want session, yeah, we can have session or not. We can we can cancel. So guys, the same example, guys, I'm moving my data to compute. I'm moving my data to a processing unit, ETL. What sort of distributed file system it is, guys? What sort of distributed file system it is? I'm moving my data to the computation engine, processing unit. Can you name it? Can you name it? Wonderful. It's computational intensive. So now I'm keeping my storage and computing in a same grid, same computer. So what I can say, guys, this type of approach, what I can call, guys, can I call data intensive? Wonderful. Right. Now you have to understand one more very important stuff called IOs. What do you mean by IO channels? If somebody say IO channel, what does it mean? This is also very important. Of course, IO channel is input output channel. What is the purpose of input output channel? Wonderful, Pankaj. So let me explain this concept. This is very important, guys. So guys, let's say that you are purchasing a laptop. So what are the things you're going to look at it if you want to buy a laptop, guys? Let's say that you want to purchase a laptop. What are the things you're going to look at it if you want to purchase a laptop? Apart from price, guys, what is the most important configuration I'm going to see, guys? Can I say processor? Because RAM and storage I can add externally, right? Processor I cannot change frequently. So processor is the one which I'm going to look at it. All right, like i5, i7, quad core, all those are nothing but my processor. Why I'm going for a good processor, guys? What I'm going to get in turn if I buy a good processor? What I'm going to get if I'm buying a good processor? All right, can I say speed? NFS, need for speed? Wonderful. All right, you're going to get a speed. But how I'm going to get a speed? All right, how I'm going to get a speed? Question. So imagine that you have two similar tasks. So if one guy is performing the entire task, he will take 10 hours. All right. If 10 guys are performing same task, all right, how long it going to take, guys? 1 hour. What is this approach? Can I say parallel processing? Can I say parallel processing? So how you're getting a parallel processing? All right, with the help of this processor IOs. All right, with the help of this processor IO. So here one IO channel is processing your task. So it will take 10 hours. If you have more IO channels, it's going to finish your task in an hour. So can I say that if I get like more IO channel, more parallel processing, I'm going to get it? Yes. More IO channels, more parallel processing, I'm going to get it? Yes. Wonderful. So now imagine that I have a quad core processor. Now let's calculate number of IO channels. So I have quad core processor, for example. So quad means how much, guys? Quad means how much? 4. All right, so basically I have how many cores available, guys? I have 4 cores available in quad core. All right, each core is nothing but a CPU. Each core is nothing but a CPU. Each core is nothing but a CPU. And each CPU does have 2 IO channels. So if I have quad-core computers, I'm going to get 4 CPUs. And how many IO channels I'm going to get it? 8 IO channels. So that means with quad-core processor, I can run 8 tasks in parallel. All right. So because I got like 8 IO channels. Now same example, guys, if I have octa-core processor, how many IO channel I'm going to get it? If I have octa-core processor. So can I say 16? Wonderful. If it is dual core processor, how many IO channels I'm going to get it? Everybody, if it is dual core processor, how many IO channels I'm going to get it? How it going to be 2? How it going to be 8, guys? Dual means 2 cores. All right, 2 into 2 IO channels. 4 IO channels I'm going to get it. Right? So guys, in your screen, what type of processor I have, guys? I have a machine with 4 IO channel. What sort of processor it is? It's a dual core processor. It's not quad core. It's a dual core processor. Okay. Now, for example, now if you come here in a distributed file system, so now if somebody asks you how much distributed IO channels I'm gonna get it here. So what could be your distributed IO channels? How many distributed IO channels I'm gonna get it? All right. So guys, quad core means how many IO channels, guys? 4 to 8. So 8 into 100. Can I say 800 IO channels? Yes, all agreed? Vikramjit, Shilpi, Pankaj, Santosh. Yeah, cool. So guys, if I have 10 machine of 4 IO channels, how many IO channels I'm gonna get it? Can I say 40 IO channels? So if one machine is taking 43 minutes to process this 1 terabyte of data, 10 minutes will take, like 10 computers will take how much time? 10 computers will take how much time? Of course, 4.3 minutes. All right. So with this knowledge, now let's discuss about the Hadoop. So can I say Hadoop is an open source framework? With the help of this framework, it is allowing you to store and process unlimited amount of data or huge data sets. All right. And that to distributed and parallel fashion. So basically, Hadoop is allowing you to store and process unlimited amount of data. So you can store your data in distributed file system, and you can do distributed processing with the help of MapReduce. So can I define something like this now at this point of time? At this point of time, can we say this? Yes. Can we define Hadoop something like this? All right, Hadoop is a framework which is allowing unlimited storage and unlimited processing to work out with huge data set. All right, Hadoop is highly scalable and uses commodity hardware. What do you mean by commodity hardware? What do you mean by commodity hardware? So can I say cheap hardware, what we and you're using, not a premium hardware, right? What we are using at home. In fact, you can use any cheapest computer here in your Hadoop cluster, right? But you know what is commodity hardware, but what is scalability, guys? So there are two types of scalability. Can you help me to understand what are my different scalability? So one is scale up, right? Another one is scale out. Oops. Another one is scale out. Scale out. All right. So if I see scale up, all right, what does it mean scale up, guys? What do you mean by scale up? I got few answers, correct answer already. What do you mean by scale up? Both are scaling. All right. So increasing the hardware capability of a single machine, increasing the hardware capability of a single machine, we can call it as scale up. Imagine that I have 4 GB of RAM. I have upgraded to 8 GB. That is nothing but scaling up. All right. Increasing your hardware capability of a single machine, you can call it as scale up approach. All right. So scale up approach. So this type of scaling, can I call vertical scaling? Can I call vertical scaling? Wonderful. On other hand, you have scale out approach. So increasing the hardware capability, or no, increase the number of computer to a existing cluster, increasing number of computer to an existing cluster, you can call it as, you can call it as scale out. All right, I can increase my computer further, increase my computer further if I need. If I need as many computer, I can add to existing cluster. So can I call this type of scaling a scale out approach? So I'm increasing the hardware capability, like I'm increasing number of machine to my existing cluster. Can I call this as a horizontal scaling? All right. If I increase the hardware capability of a single machine, it's going to be vertical scaling or scale up approach. If I'm adding as many number of computer to the existing cluster, I'm going to call it as scaling out approach. So in our use case, what Hadoop uses, guys? Can I say Hadoop uses scale out approach. And Hadoop uses scale out approach. Wonderful. Got it? Somebody asked this question. Vikramjit Singh. Yeah, cool. So now with this, guys, can I say Hadoop is economical? Hadoop is economical, guys. I'm using cheap computers and it is an open source framework. I need not to pay anything for license. With this, can I say Hadoop is economical? Can I say Hadoop is highly scalable, guys? It follows scale out architecture. All right, one of the key characteristic. Can I say Hadoop is highly flexible? It accepts all type of data. It accepts all type of data. Hadoop is very much reliable also. That point we're going to discuss in the architecture section. Why Hadoop is very much reliable. All right. Reliability means if part of my compute, like if one of my computer loses, I will not be losing my data. So you have like some fault tolerance mechanism, which we're going to discuss in detail in our next class. All right. At this point of time, while designing Hadoop, the technologists have considered some of the points. right? So can I say we have achieved the point? We are facilitating unlimited storage and unlimited processing. Yes, I won't answer in yes, no, maybe. Right, wonderful. All right. So can I say it can work with all type of data, structure and unstructured? Yes. Can I say it is scale out rather than scale up? Santosh, for that also you have got maybe answer. No, it can process all type of data, right? So it's scale out rather than scale up. This is very clear. So guys, what is this concept called? Bring processing to data. All right. Bring process to data rather than data to the processing. What is the first approach and what is the second approach? The first one is data intensive approach. Other one is computation. Superb. You know this. So you know high scalability, you have a scale out architecture. We know that we are using commodity hardware, and there is a reliability feature which we're going to discuss in detail next. So guys, now give me one point about like difference between structure and difference between RDBMS and Hadoop. One point from everybody. Right, difference between RDBMS and Hadoop. Everybody. All right, one is first one I got it from Pavan. Hadoop is for huge data set. RDBMS limited. All right, that point is covered. Guys, quickly, I want everybody. Shilpi says RDBM has a fact and dimensions. Very good. Good point. So basically, RDBMS does have a schema. All right, lot of schema topologies are there, but in Hadoop, you don't have any schema. Cool. Wonderful. Biswajit says that RDBMS only structured data, but Hadoop all type of data. Ankit say RDBMS is open source, RDBMS is licensed, Hadoop is open source. Very good. Wonderful. All right, you have given almost like all the points. RDBMS is expensive and Hadoop uses commodity hardware. Cool. All right. Can you say data intensive, computation intensive? Yes. All right. Can I say scalability? RDBMS scalability is very much limited. I can scale out my RDBMS, but it's very complex and it's very limited. Right? So Teradata use data intensive approach. Yes, that is the one of the type of distributed file system. Any system can use it. Okay, wonderful. I got like most of the point, guys. Now the Annie's question, the Annie's second question. It's a LKG question. Hadoop framework is designed for distributed processing of wide design, guys, for large data set. Wonderful. So Hadoop ecosystem, guys, what are my data loading techniques we have learned already? You have to name. You have to name. What are my data loading techniques? You have to be fast, guys. Now, data loading technique is going to be Flume and Scoop. What is my data storage system? Data storage system, HDFS. Processing system. What are my different processing system? MapReduce, Hive, Pig, Spark also I can consider. Spark also I can consider. Wonderful. What are my, all right, there is a one of the machine learning library called Machine Mahout. All right, now it's got like deprecated. You got like Spark MLlib, right? So basically all machine learning libraries or modeling can be done with the help of Spark MLlib. This technology is kind of like deprecated, you can say, for machine learning analysis. So what is guys workflow system, guys? What is my Uzi, like what is my workflow system? I've answered already. All right, what is my big data workflow scheduler tool, guys? Which tool I can use? Can I say Uzi? Wonderful. So now, guys, there are two versions available, 1x and 2x. All right, this you have to keep in your mind, guys, always. The 1x series, there might be some problem with 1x series. That's the reason they have introduced 2x series. So this 1x series, you can call it as a name called classic Hadoop. So whenever I refer classic Hadoop, something I'm not able to write it here. Classic Hadoop, guys. So I can call it as classic Hadoop. All my Hadoop 1x series. What is HBase? What is HBase, guys? It's a NoSQL database. All right. Okay, very good. So got it. We haven't discussed that. Yes, we have discussed that, right, Pavan? Yes, you have shared my name. You have to be more faster than me. Cool. So guys, 1x series, like all my Hadoop version 1.x or 0.18, all this version, you can call it as classic Hadoop. All right. So there might be some problem which we're going to discuss in our coming classes. All right. There might be some differences. They have some problem areas which is covered in Hadoop 2x series. So all my versions starting with 2.0, 2.4, 2.5, all these are nothing but a yarn. All right, so you can call it as yarn cluster. All my Hadoop versions, Hadoop 2x version, I can call it as Hadoop 2x or I can call it as Hadoop yarn. All right. Here definitely you're gonna have like some more component, all right, which is actually kind of like problem. Like with classic Hadoop, they have overcome that. Here they have introduced yarn cluster resource management. At this point of time, I'm not worried like what is the actual difference. All right, we're gonna learn like first what are the challenges with my previous classic Hadoop, then how we have overcome in yarn. We're gonna learn systematically. All right. So machine learning with Mahout, guys, the only way to write a machine learning with Hadoop is Mahout. But now, all right, older application is still running in Mahout, but like all the latest application, if you want to build any machine learning models, all right, I have to use MLlib. But earlier, like Hadoop and MapReduce, like Hadoop and Mahout I'm going to use for machine learning analysis. So Mahout is nothing but a set of libraries available, all right? And those library I can use it in my MapReduce job. So actually it become very complex and very huge amount of line of code I have to write it. So that's the reason like people shifted to Mahout. Now the last discussion for today, guys, what are my daemons? What do you mean by daemons first? What do you mean by daemons, guys? Right. So can I say daemons are nothing but a background process, background Java process? Wonderful. So if you want to make my software up and running, or if you want to make framework up and running, there should be some software which needs to be run in the background. There should be some software which needs to be run in the background. Am I right? All right. So those are nothing but my daemons. So in order to make my Hadoop up and running, there should be some daemons needs to be up and running, right? If I want to make my Hadoop up and running, all right? So Hadoop does have how many core component, guys? Hadoop does have how many core components? Come on, guys, I need answer. HDFS and MapReduce. These are the two core components. Cool. So if I want to make my storage up and running, what is needed, guys? There should be some daemons. All right, you have some daemons like name node. Right, you have some daemon like data node. Right, you have a daemon called secondary name node. Secondary name node. I'm sorry, guys. All right, so for processing, I have two set of daemon. So if I'm using 1x series, what is the other name I can give for 1x series? What is the other name I can give for 1x series? Classic Hadoop. Somebody say classical. No, it's classic. All right. So now for if it is classic Hadoop, guys, all right, earlier 1x series, they have daemon name called job tracker. All right. And they have a daemon name called task tracker. All right, same daemon in 2x series, you got a different name. So in 2x, all right, job tracker will be represented as a resource manager. Job tracker will be represented as a resource manager. And your task tracker will be represented as node manager. All right. So if somebody asks you how many processing daemons needs to be up in the background, how many processing daemons needs to be there in the background? If somebody asks you this question, what could be the answer? Processing demands, not storage. All right, the answer is 2. I just asked processing daemon. If I would have asked how many Hadoop daemons needs to be run in the background, then what could be the answer? 5. Wonderful. Right. If somebody asks you how many storage daemon, what could be the answer? Answers from everybody. Now answer is 3. Yes. Okay. So guys, right. Usually my HDFS and MapReduce follow master-slave architecture. So usually in master-slave architecture, guys, how many masters you're gonna expect usually? Usually 1. So basically you need not to worry about it. The master component of HDFS is name node, and master component of my MapReduce is either job tracker or resource manager based upon version. And you can have unlimited slaves. So your data node or task tracker and node manager are nothing but a slave computer. Now one generic question, last question for the day. So can I keep this data node and node manager in the same computer? Oh, I got only correct answer from Ankit. Guys, didn't I taught you in data intensive storage and processing slave has to be in a same machine? Didn't I taught you? So now everybody can say, if I want to achieve data intensive, can I say storage and processing slave has to be in the same machine? Yes, no, maybe. Right, I got only 6 yes. What about others? Cool. Wonderful. All right. This is important point you have to keep in your mind. Tiger, we are tigers. All right. So storage and processing in the same computer. Cool, guys. So now in tomorrow's class, we're going to start our discussion with architecture, and then we're going to see some hands-on commands with HDFS, and then we're going to see does same go for name node and resource manager. It is not mandatory, and actually that is a part of your future discussion. So that is the reason I don't want to take now. All right, but since you got this question, it can be in the same machine, it can be in different, no rules implied. Any pre-setup required for tomorrow class? No pre-setup required. All right, guys, if you are from a, if you know basic Unix command, that is more than enough. I hope everybody knows Unix commands, like how to copy. Yes. All right. If no, you have in your LMS. All right. If you go to your LMS, all right, you can have practicals. All right. Inside practicals, you have Linux command. You can practice those Linux commands. Okay. All right, guys. Hope you have enjoyed the session. So, guys, every day you have to make an habit, guys. Every day, once you finish the class, or you're gonna get like after you close this session, all right, you're gonna get a feedback form. All right. Please do participate. All right. So if you like the training, you can go for excellent. If you don't like the training, you can go for uh, good or good, bad or average, any other rating. It's same altogether. All right. All right. And everybody has to take part of the service every day. All right. Every class. That means you've been awesome. Thank you very much. Do we have any assignment for today? No. Sit back and relax. All right. Time will come. So no work for tomorrow. You're amazing. Thanks, Santosh. Thank you, Shilpi. All right, guys. Right. I love to see those comments in the feedback form. And let's see. All right. Let's come tomorrow with the same energy. We're going to do rest of the stuff. Will this training video will be posted in Edureka portal? Of course. All right. You're going to hear my voice lifetime. Punishment. Do you have access to slide lifetime? Yes. Yes. Lifetime access. Lifetime association with Edureka. All right. See you then, guys. Enjoy your. All right. I think most of the people from US. So enjoy your work, and Indian guys, enjoy your sleep. When this will be posted, I think down the line, 1 hour, within few hours, you're gonna get it, Balaji. Or 1 or 1.5 hours, they're gonna take a time. See you then. All right. So rest of the questions, you can make it, you can keep that for tomorrow, and we'll be meeting tomorrow at 8:30. See you then. Bye bye. Bye. Good night for this session. Thanks. Will you take any other courses? Yes, I do take all Hadoop related big data stack. This is my 169th batch in all technologies together. Cool. Bye bye.